Hi everyone, welcome back. In today's video, we'll be going through this challenge question right here, which requires a elevated holistic application of the formula of a slope of a line, also a substantial understanding on coordinate geometry as well. So in last video, we have talked about what is a slope, what is a general formula for slope, how to derive this slope, and three classical question types regarding that topic. So let's delve right in. In the diagram shown, ABCD shows a piece of geometric art on canvas with dimension 58 cm times 78 cm. The point N is the midpoint of BC, and the point M is the midpoint for AB. Suppose there exists a point X on AC such that the ratio AX to AC is equal to 1 to 5. And the straight line connects M to the point X. Also, Y is the point where AC intersects the line ND, determining the area of the shaded area. So basically, what we are looking for is the area of triangle AXM plus triangle DYC. So this is the total area that we are looking for, which consists of two parts, and both of them are a triangle. And some conditions said in the question, we can mark it on the diagram actually. So N is the midpoint of BC, and M is the midpoint of AB. And we can actually calculate the distance of BN, NC, AM, and B respectively, because we know the length and width of the triangle. And also we know that AX to AC is 1 over 5. So if we say this is 1, the rest of the segment AC, which is XC, would be 4. So this is the cutting point. So AX is 1, X is 4, so in total 5, and AX is 1/5 of the whole thing. So, after we put all of the information stated in the question down to the diagram, we can actually start to think about the strategy on how we can get these two areas, these two triangles areas. So, one strategy that I used is a theorem called shoelace theorem. Shoelacing theorem. So how does this work? So this theorem says if we know all the coordinates of a particular polygons, like this, like a triangle, let's say, which has a coordinates of A, B, points which is vertices of A, B, C, and A has x1, y1, B has x2, y2, and C has x3, y3. Then we can actually say the area of triangle ABC equal to 1 over 2 times, we can list x1, x2, x3, y1, y2, y3. So how can we do this? We basically use we multiply x1 with y2, x2 with y3, and we add up those two results. And then we multiply y1 with x2 and y2 with x3, and we also add up those two results. And then we subtract these, we do a subtraction between these two results and the absolute value of the whole thing times 1 over 2. That would be the area of triangle ABC. If we are I know that maybe you're a bit perplexed or confused at this point, but when we actually reach this point in the question, you'll be quite clear. So, how can we do this? We want to use the shoelace theorem, which requires all the coordinates of the triangles. But there's no Cartesian plane in this diagram at all, so where's all the coordinates coming from? Therefore, our most important starting point, the key point in this question, is learn to construct a Cartesian plane on a existed diagram. How can we do that? So we can actually put a y-axis down along the line AB. And this line is a bit too not really aligned. Oops. Let's see if I can actually drag it a bit to the left side. Nope, but you guys get the idea. And then another line, we can actually put the x-axis along the line BC. So this is x-axis, this is y-axis, which is really bad drawing. So I'll just redraw it a bit better. So this is y-axis, and this is the origin point, so B. This is 0, 0. So what is the coordinates of A, or M, or X, or probably on the under the triangle D, Y, C? So do we have any ideas on the coordinates of any of them? So let's take a look. So probably we can start from point A. Point A has a x value of 0, that's for sure. And what is the distance of its y value? It is actually 58, which is the width of this rectangle. So the coordinates of A would be 0, 58. And also the units are consistent throughout this question, which is centimeter. So at the end, when we are solving for the area, it would be centimeters squared. And then what about M? Since M is the midpoint of AB, so we can actually solve for the distance of MB. So MB would be 58 divided by 2, which is 29. So this would be the y value of M. Do we know the coordinates of X necessarily? Do you have a way to calculate the X value that corresponds or the Y value that it corresponds? No, we don't. So let's skip to the next one. Let's do D. So D has a X value of 78 because this is the length of the rectangle, and it also has a Y value of 58, which is the width of the rectangle. And then what about C? We can also figure out the coordinates of C because it has a X value of 78 and a Y value of 0 because it lies right on the x-axis. What about Y? Y has a same ambiguous situation as point X. So we have no way to mathematically calculate its X coordinate or Y coordinate. So these 4 points are essentially the points that we know on this graph. Well, in the 3 triangles. What about other points? Do we have any ideas on any other points? So for sure we know B, which is 0, 0. We can also figure out N, which is actually because it's a midpoint, this is half of 78, which is 39. So it should be 39, 0. So these are the points that we can actually figure out in this question so far. And now we need to figure out a way to solve for the coordinates of X and Y. So how can we do that? So first, if we want to solve for these 2 points, we should tie it back to the application of the slope of a line. So how can we get some equations of a line? Why getting the equation of a line? Because if we look at point Y, it is right at the intersection of segment ND and segment AC. So if we can figure out the equation of line AC and line ND, we can actually form a system of equation and solve for the coordinates of Y. So see, this question not only incorporates the slope of the line, but also equation of a line and the intersection of multiple lines. So next, our goal is to figure out the equation of line AC and line ND. So what are some factors that plays a significant role in solving for equation of a line? Yes, the coordinates of at least 2 points. So let's take a look at AC. We do have at least 2 points on this line to solve for the equation, which is A and C. Same thing applies for segment ND, because we have the coordinates of point N and point D. So let's do it. So for line AC, we actually can say it's equal to y equal to mx plus b. That's the general formula for a straight line. And then our favorite slope comes into play. So m should be equal to y2 minus y1 over x2 minus x1, a simple recap from last class. And then we can say that because we are using point A and point C. So let's say for A, it's always x1, y1, and for C, it's x2, y2. So it should be 0 minus 58 over 78 minus 0. So we would get something like negative 58 over 39x. And then we want to substitute this slope back in, y equal to negative 58 over 39x plus plus b, and then we substitute any of these two coordinates into this equation to find b. Let's just say a. So if we substitute this 0 in, we can see that b equal to 58. So let's tidy things up a bit. So let me just erase all the calculation parts, because we already know that. So we will know that the equation for line AC is y equal to negative 58 over 58 over 78 plus 58. Okay, so now we also want to do a simplification of this slope right here. So after simplification, it would be 29 over 39x plus 58. So if we apply the same strategy to ND, we can actually successfully obtain that the equation of ND would be 58 over 39x minus 58. So now we have this two equations for the lines. And if we go back to the diagram, we can see that point Y lies right at the intersection of these two lines. So if we form a system of equation, we can say y equal to negative 29 over 39x plus 58, y equal to 58 over 39x minus 58. And if we solve this thing, which I'll just skip all the steps right here, which is a simple substitution, and it becomes a one variable equation, we can get 87 over 39x equal to 116, so x equal to 52. This is the x value for point Y. And then if we substitute value in any of these equations, we can actually get the y coordinates of y, point Y, would be 58 over 3. Therefore, we can actually get the coordinates of point Y is 52, 58 over 3. Next, after solving for Y, so we know AM. For the another triangle, we have DYC. So for triangle DYC, all the three coordinates are known now. However, for triangle AXM, we still don't know X yet. So after we figure out the coordinates for point Y, it's time for us to solve for the coordinates of point x. So how can we do that? So on the whole question, there's still a condition that we haven't used yet, which is this piece. Ax to xc is 1 over 5. So if we draw a diagram for something like this, if we look at this closely, let me highlight the part that I want you guys to examine, which is this part, this part, this part, and this part. What does this shape remind you guys of? What does this shape resemble in mathematics? We can actually think about this as a similar triangle model, isn't it? So the triangle X, this I'll say P, XPC, this triangle is actually similar to the bigger triangle ABC right here. So how can we utilize this information? So based on the property of similar triangle, we can actually obtain something like this. So AC over XC should equal to BC over this PC. So this is the relationship of similarity that we can obtain from this similar triangles. So now let's copy this equality down so that we can have a better understanding. So now we want to substitute some value in. So what is AC? So AC in this case would be a simple Pythagorean theorem. So it would be root 78 squared plus 58 squared over xc. However, do we really need to solve for this value though? No, we don't. We are looking for a ratio. So in the question it says ax to ac is 1 over 5. Then what is the ratio between xc to ac? It would be a 4 to 5 ratio. And bc to pc would also be 5 over 4, this ratio. So BC is 78, and PC is what we are looking for. It's only unknown here. So after cross multiplication, we can get 5PC equal to 4 times 78, and we can get PC equal to 4 times 78 over 5, which is approximately, actually we'll just leave it there, right here, right for, just for now. And then after knowing this, we can actually, some magical things will happen right here. So we actually want to tie this value back to the x coordinate of point x. So the x coordinates of point x should be the distance between B and P. We know BC for sure, which is 78. We also just calculated PC. So BP should just simply be BC minus PC. So which equal to 78 minus 4 times 78 over 5, which is 15.6 centimeter. So this is how we can get the x value of point x. And then we also want to get the y value of point x, which is the distance of xp. So we can obtain another equation of similarity again, which will still use AC over xc equal to AB over xp. So this is the similarity equation that we are going to use to solve for the y coordinate of point x. So let's take a look. So AC over XC is still 5 over 4, but this time AB is 58, I remember, yes. And XP is the one we are looking for. So XP, after cross multiplication, it would become 4 times 58 over 5. So is XP the y-coordinate? Yes, because the distance, this part corresponds exactly to the y coordinates of x. Therefore, the y value of point x would just be 4 times 58 over 5 equal to 46.4 centimeter. Therefore, after these two procedures, we can actually successfully obtain the coordinates of x, which is 15.6 and 46.6. And now we gathered all the informations we want to know to apply shoelace theorem. So we want to do the triangle AXM first, then the triangle DYC. So let's do triangle AXM first. So first, let's list all the coordinates that we know. For A, we want to know A, X, and M. So for X, we know for sure it's 15.6 and 46.4. And let's just double check with A. I remember it's 78, 0.58. And for M, it should be 0.29. And for another triangle DYC, we actually want to know the coordinates for D, Y, and C. So for D, we should have 78, 58. For Y, we should have, let's double check. We should have a 52 and 58 over 3. And for point C, we should have 78, 0. So for each of these triangles, we have all the necessary components of information that we need to solve for the areas for both, respectively. So apply for shoelace theorem. I'll just do one of the triangles for you guys to let you guys know how it works. So the area equal to 1 over 2 times, let's list the coordinates down, 0.58, 15.6, 46.4, 0, and 29. Now, we want to use 0 times multiply with 46 times 4, 0.4 and 15.6 times 29, and add up them. So 0 times 46.4 times 15.6 times 29. And then we want to multiply the opposite direction as well. So these two and add them up. So 58 times 15.6 plus 46.4 times 0. And then we do a big subtraction between these two values. And we will get some sort of values. And then we do an absolute value of the whole thing and then times 1 over 2. And the answer should be 226.2 centimeters squared. The same strategy works for here, and I'll just leave it as a practice for you guys to reinforce your understanding of shoelace theorem. And then at the end, eventually we should get the area for triangle DYC is equal to 754 centimeters squared. Therefore, hence, the total area of shaded section should be equal to the area of AMX and area of triangle DYC is equal to approximately 980.2 centimeter squared. And this would be the final answer for this monstrous question. This is quite challenging. I think that's all for today's video. Thank you for watching and have a good day.